Okay, we're now going to look at some integrals of graphs who have areas above and below the x-axis. So, what you'll have learned is that areas that are below the x-axis will generate negative results, but you ignore the negative and count the area as being positive. So you would generate possibly an answer like -2 there for that area, but that means its area is actually equal to 2. If the area up here was 1.5, then you would generate that result because it's above the x-axis. But if it's below the x-axis, you'll generate a negative result, but you ignore the negative, so a -2 result is 2. So the total area here then would be 2 plus 1.5, which is 3.5. We're now starting to get into the realm of explaining what integration is about, and it's linked to calculating area. So let's try a couple examples here. And example 1. Okay, we're going to calculate the shaded area in this question. Okay, so these two shaded areas, we're told the x-coordinate here is 2 and that the x-coordinate here is -4. We're also told that that straight line is y equals x plus 4. Okay. We're also told here that that's -6. Now the way you approach these questions is you calculate the area distinctly above the x-axis separately, and then the area that's distinctly below the x-axis separately. You get two separate answers and you add together to get the total area. So let's first of all concentrate on this area here, which has an upper limit of 2 and a lower limit of -4. Okay, and we're integrating the function which is x plus 4. Okay, so add 1 to the power, divide by the new power. That will be x squared over 2 plus 4x between 2 and -4. So that's now ready to make a substitution. 2 squared over 2 plus 4 lots of 2, close the bracket, minus open up. And it will be -4 all squared over 2 plus 4 lots of -4. Okay, so 2 squared is 4, 4 divided by 2 is 2, plus 4 lots of 2 is 8, minus open up. -4 squared is 16, 16 divided by 2 is 8, and 4 times -4 is -16. Okay, so that's now equal to 10 minus 18, take away 16 is 2, 10 take away 2, and that is 8. So I've calculated the area here, marked in blue, is equal to 8. Let's concentrate on this area here, between -4 and -6. So I'm going to integrate. The upper limit is -4, the lower limit is -6. So I should probably expect to get a negative result here because it's below the x-axis. And I'm integrating x plus 4 because that's the function. So x squared over 2 plus 4x between -4 and -6. Okay, so -4 all squared over 2 plus 4 lots of -4, close the bracket, open up, -6 all squared over 2 plus 4 lots of -6. Okay, so -4 squared is 16, 16 divided by 2 is 8, and 4 times 4 is -16. Minus open up, -6 squared is 36, 36 divided by 2 is 18, 4 times -6 is -24. So 8 take away 16 is -8, minus 18 take away 24 is -6. So that's -8 plus 6, which is -2. So as expected, I get a negative result there, but I ignore that negative, and the area below there is 2. So I'm going to take the area below, which is 2, plus the area above, which is 8, to get the total area, which is equal to 10 square units. Okay, let's try an example 2, and I want to find the shaded area below the x-axis of this parabola. Okay, now I'm not going to provide the limits, we're going to work those out. Now you can see that the limits are the roots. How do you find the roots? You solve the quadratic equation, so let's do that first. Difference of two squares, and that will give me x plus 1 equals 0 and x minus 1 is equal to 0. X equals minus 1 and x equals 1. So my limits then are minus 1 and 1. Okay, so I can now integrate. So the upper limit being the greater value, which is 1, the lower limit being the lesser value, which is minus 1, and I'm integrating x squared minus 1. So that's going to be x cubed over 3. Remember, if you integrate a constant, it becomes a constant x. Minus 1 will become minus x between 1 and minus 1. Okay, so that's 1 cubed over 3 minus 1, close the bracket, minus open up, minus 1 cubed over 3 minus 1. Okay, so that's 1/3 take away 3/3 minus 1 cubed is minus 1. So it's minus 1 over 3 minus 1 is plus 1. So minus 2/3 minus 1/3 plus 3/3. Okay, so that is minus 2/3 minus 2/3, which is minus 4/3. So I'm expecting a negative result since it was below the x-axis, but I know to ignore that, and the area is given by 4/3 square units. Okay, let's try one more. And I want to find the shaded area. The function is x squared minus 5x plus 4. Okay, so I can see that this part here is x equals 0, but I need to find the root here and the root here. So how do I find the roots? Solve the quadratic equation, make it equal to 0. Two numbers that multiply give 4, add together give minus 5. So it's going to be minus 1 and minus 4. Minus 1 times minus 4 is 4. Minus 1 minus 4 is minus 5. So I've got x minus 1 is equal to 0 and x minus 4 is equal to 0. X equals 1 and x equals 4. Let's feed them in now. Okay, so I'm going to do these distinctly and separately. So let's first of all find this area here, which is between 4 and 1. Okay, so add 1 to the power, divide by my new power. That will be x cubed over 3 minus 5x squared over 2, and a constant becomes a constant x, so 4 becomes 4x between 4 and 1. Okay, so that's going to be 4 cubed over 3 minus 5 lots of 4 squared over 2 plus 4 lots of 4, close the bracket, minus open up. 1 cubed over 3 minus 5 lots of 1 squared over 2 plus 4 lots of 1. Okay, so 4 cubed is 64, so that's 64 over 3. 4 squared is 16, 16 times 5 is 80, 80 divided by 2 is 40 minus 40 plus 16 minus open up. 1 cubed over 3 is 1/3. 1 squared is 1 times that would be 5, that's 5, so that's minus 5 over 2 plus 4. Okay, so 64/3 minus 24 minus open up. And let's change this to 6, that will be 2/6 minus 15/6 plus 24/6. Okay, so that's 64/3 minus 72/3 minus open up. 2/6 take away 15/6 is minus 13/6. Minus 13/6 plus 24/6 is 11/6. Okay, so 64 thirds take away 72 thirds. That will be minus 8 thirds minus 11 sixths. So let's change the thirds to 6. That will be minus 16 sixths minus 11 sixths, which is minus 27 over 6. I can divide top and bottom by 3. And that will bring me down to minus 9 over 2. So the area then for that particular bit is 9 over 2 square units. So remembering that I ignore the negative, I expect to get that result because it was a distinct area below the x-axis. So let's try the area above the x-axis. Okay, so this time the upper limit is 1 and the lower limit, as we can see, is 0. And again, I'm integrating x squared minus 5x plus 4. Okay, add 1 to the power, divide by new power, x cubed over 3 minus 5x squared over 2 plus 4x between 1 and 0. Okay, so that will give me 1 cubed over 3 minus 5 lots of 1 squared over 2 plus 4 lots of 1, close the bracket, minus open up, 1 cubed, 0 cubed rather, over 3 minus 5 lots of 0 squared over 2 plus 4 lots of 0. Okay, so that's 1/3 minus 5 halves plus 4 minus, and that all collapses to 0. So let's change this to 6. So 2 sixths minus 15 sixths plus 24 sixths. And that will give me 11 sixths. So the area above the x-axis is 11 sixths. Okay, so total area then is 11 sixths plus 9 over 2. Let's get a common denominator 6. So that's 11 over 6 plus 27 over 6. 30 over 6, which I can now simplify by dividing top and bottom by 2. Final answer then will be 19 over 3.